Well, hello, and welcome to the Novare Science virtual conference booth. I went to conferences for 15 years, but I knew eventually I was going to have to cut back on the traveling as the years went on, and now we're there. So I can't be with the conference people as much as I used to be. So I'm making this video so that I can talk to people as if I were in the booth, and you can hear from me an introduction to our products. So in this video, this is a longer one. We have a shorter version too. I'm gonna pretend that you, the viewer, are a customer who came up and you told me, wow, I've heard about Novare Science, but I don't really know anything about it, and we're considering whether we ought to switch to Novare, and what can you tell me about it? And I'm going to assume that you have maybe 20 minutes that you're willing to spend and visit about this, so that's what I'm going to do in this video. So I like to start by, well, what usually happens is people pull one of these books off the rack and they want to hold it and touch it, and their first experience with a Novare text is, wow, these are small and they're lightweight and they look good and they're slim, easy to carry around, easy in the backpack. So there's a very tactile draw to these books that people experience in the booth when they come and visit with us. But while they have the book open or out and open, I like to point out that inside these books, they're beautiful, right? These are not ugly books because we believe in beauty. And we believe that beauty leads people to God, the source of all beauty, and makes them lovers. If they encounter enough beauty, it makes them want to become a lover of truth, goodness, and beauty. Beauty is very important to us. So all the books are beautiful. They're small, too, which is a result of our mastery learning paradigm. So I'll come to that in a second, after I kind of introduce you to the overall line. We have a full curriculum line from 6th to 12th grade, and these books have many very unique features, which is why Novare Science has been growing from when we started back in 2009. We're still growing rapidly because people discover Novare Science and they don't want to go anywhere else. Starting in 6th grade, we have life science. 7th and 8th grade, 7th grade is physical science, 8th grade is earth science. Then beginning in 9th grade, we have two different pathways. We have a grade level pathway and we have an accelerated pathway. And the difference is essentially where the student is in math. So a 9th grader in the grade level pathway would be in Algebra 1. A 9th grader in the accelerated pathway would have already completed Algebra 1 the previous year, generally, and would be in geometry. So notice that in 9th grade for everybody is introductory physics. This book here is also introductory physics, but it's physics and chemistry. Goes at a faster pace, covers essentially the same physics, but gets into an introduction to chemistry starting in March and going through the end of the year. There are huge benefits to putting 9th grade physics for everybody, which I'll mention in a little bit. And so we're real big believers in physics first is what we call it. Now, after the introductory physics in 9th grade, then in the grade level pathway, the students after that will take biology, general biology as a sophomore, and then general chemistry. And then in 2025, we will have out our environmental science text, which would be their senior science course. In the accelerated track, students start out with the introductory physics and chemistry. Then they go straight into their chemistry class, and this chemistry course here is, it covers almost all of the AP syllabus for chemistry. So it's a very rigorous text. Then advanced biology, and again, this is basically biochemistry introduction, and again, it covers the entire AP syllabus, and it's designed for students who've already had chemistry. And then we have for seniors vector physics. So this is where the students who really need the more advanced physics class that uses vector methods in the problem solutions, that's where that shows up in our program. These cards on this display stand, they show the extra resources that are available to go with each one of these courses. And they're kind of different for different courses, so I put these cards here so that you can see what things are available with each different book. And in this like 20 whatever minute video, I can't go over all the details of all these extra resources, but I'll summarize them for you. For all the high school texts, there are experiment manuals. For the ones that have a lot of math, which is basically physics and chemistry, there are solutions manuals that have complete solutions worked out for every problem in the book. There's also a digital resources package that goes with every text. We call it a download, digital resources download. You access it through your account at Classical Academic Press, and there's about 100 documents in there for each text. It includes a year's worth of quizzes and or tests. It includes for younger grades 6, 7, 8, and 9 weekly review guides, which I'll get to in a second. And it includes a PDF file that has answers in it to all the quizzes and tests for the tutor, parent, teacher. And it has guidelines on recommendations for teaching the class, a sample schedule, a lesson list. So really a whole package of documents that you need to run the class. There are, as I mentioned, there are experiments books for all the different books. For the 6th, 7th, and 8th grade books, the experiments are in the text, and the manual is a digital manual that's part of the digital resources. All right, now let me shift gears and just talk a little bit about what makes our curriculum so attractive to people and so unique. And this boils down to two questions that I was trying to address when I first started teaching at a classical Christian school in 1999. And the first was, how do we teach science classically? Which back then no one had an answer to. How do we make it classical? So all the science teachers were just teaching the way they were taught, which is basically how you were taught in the public school, which is not a classical methodology at all. And the second question relates to this pattern of behavior that I saw everywhere, not just in science, but in every kind of class. Students cram for tests, they pass the tests, and then 3 weeks later they forget almost everything they crammed. And to me, this was a disaster. And everybody admits it's a disaster once we talk about it, but most people just nod and say, yeah, that's the way it is. That's how I did when I was in school. But see, I wasn't willing to accept that because I think that's a disaster for education. It's ruinous. It's frustrating for the students. It's very frustrating for the teachers. So it's an exercise in futility. I wanted to figure out how can we teach so that we can get out of that cycle. Let me address that first. I developed a mastery teaching methodology that uses cumulative assessments. So in the up through 6th through 9th grade, we use weekly quizzes, not chapter tests, weekly quizzes, and they're timed, 30 minutes long. You take one every week, and they're cumulative. So about half the content on every quiz comes not from the immediate material we've studied, but from all the prior chapters back to the beginning of the year that we have studied. So we have to teach students how to study so that they don't forget, so that they're retaining what they've been taught. And in these first 3-4 grades, the way we do this is give them a weekly review guide that has a list of practice activities on it that they're going to do during the next week. And this is things like drill flashcards or practice these problems, practice saying the 3 ways static electricity can form, practice explaining how a motor works, these kinds of things. Practice these 4 new problems. So in the course, these introductory physics courses for 9th grade, there's always at the bottom of the weekly review guide 4 new problems that come from older chapters, and the answers are on the back. They should be able to work those 4 problems in just a few minutes and get the right answer. And they do this every week, so they're constantly exercising these skills. They're constantly practicing. The research shows the power of what is called the practice effect. It's also called the testing effect. It's kind of common sense. The more times you practice something, the more it gets into your long-term memory. But the research shows that there's a very strong effect. And what we're doing is making use of that by teaching the students how to practice, giving them a list of things to practice for 6th through 9th grade, and then they practice, and then when they take the quiz, boom, they know the answer. So almost nobody makes a C in any of these classes. You either are practicing like you're supposed to, and you're going to get an A or a B, or you're not. And you're not going to do well until you start practicing appropriately. But it's night and day. I've had teachers tell me that once they started using this teaching method, like the students just never forget anything. One teacher wrote one time and said that he took his earth science class out on a field trip, and the geologist that was met them there said, these students know more geology than any class I've ever been with. This is the kind of results that happen. So that's one of the key features of our curriculum, is it's all based on this mastery learning method that I developed. Mastery learning goes back to 1968, but you don't see it much because it's hard to implement. So the thing here is that I've implemented it in a way that makes it very easy to use, and the results are just really striking. Now, the other big thing I was trying to address when I was inventing this curriculum was how do we do this classically? How do we teach science classically? And by that, I really mean I came up with two answers to the question. And one of them is the motivating beginning place for all studies in science should be wonder at the natural world. The natural world, made by an infinitely wise creator, is infinitely beautiful and amazing. And in science, there should never be a day in a science class when students are feeling bored or like this is dull, because we're studying the most amazing things there are, the handiwork of the creator himself. So the books are designed to promote this sense of wonder and just giddy delight at the creation all through the books, right? So we start with wonder. Both Aristotle and Plato said that wonder is the beginning of philosophy. Well, science used to be called natural philosophy, so we start with wonder. The second big thing about teaching classically is to make sure 4 key areas are integrated into the curriculum. These 4 are epistemology, mathematics, history, and use of language, English language use. So I want to explain briefly what each of these mean. We'll start with epistemology. That's a big word that means the study of how we know what we know. How do we know things? And the thing about science is that it's a particular kind of knowledge. And it's different than knowledge we would get from, say, the Bible. Okay? The Bible is divine revelation to us. And the Bible thus contains truth claims, like God is love, right? That's a truth claim that's in the Bible. And science, by nature, isn't dealing in truth claims. Science deals in models. So what science is doing is building models of the natural world. So we have a model of gravity. It's called the General Theory of Relativity, published by Albert Einstein in 1905, or 1915, sorry. A special theory was 1905. The General Theory of Relativity is our model, our current best explanation for how gravity works. All right, so that's a model. Einstein said he thinks that someday someone will come up with a better one. All right, so scientific knowledge evolves over time as better models replace older models. So when we're talking about one of these models, we don't say things like this is true. We say it's a good model, or it's strong, or it's stronger because of the new experimental results we have. Another part of the scientific knowledge or epistemological conversation is, how does science work? It works by what I call the cycle of scientific enterprise. You begin with a theory that explains a body of facts. The theory gives rise to a hypothesis, a guess, a prediction. You test that, and the results come out. If they support the hypothesis, well, then the theory just got stronger because it led to this hypothesis that was successfully tested in an experiment or observation. So this is how science works. So the nature of scientific knowledge as modeling and the way science works, all that together is what I mean by the epistemology. Second is mathematics, which is pretty obvious what that is. I don't need to talk about it very long, except to say that all our physics and chemistry books have lots of math. I tried teaching from the books that don't have any math, the so-called conceptual ones, and I learned that students can do way more than we usually think, and they can do the math. Everybody can do the math. The math is grade level, appropriate, and they need to do the math because they not only get lots of practice at doing the math so that they become masters of it and never forget it, but it's also one of the major ways that they apply the science. So it provides another level of conceptual understanding for what this scientific principle is all about. The third area of integration is history. When we talk about the cycle of scientific enterprise and theories evolving over time, the best way to get a grip on what that looks like is to study the history of science. So we have lots of history in every book, and things like the history of our understanding of the atom, back starting in 1803 with the first atomic model, and then 1899 with the electron, and then in the early 1900s with discovering the atomic nucleus, and then the quantum model. So as you see our models of the atom evolving over the period of 120 years or so, you see the cycle of scientific enterprise at work. And the fourth area of integration is language. We're language users, and that is such a key feature of human life. I mean, just think for a moment what it means that we use language. Okay, God created the universe in the beginning by fiat, by words. Let there be light. He commanded, and the creation came into existence with his words. Jesus is the Word of God. All right, and so we know that there's a rational principle in all of creation, and that rational principle is reflected in us because we are language users. Language is so central that it's my belief that every class in the school needs to be doing its job to help students become good users of language, readers and writers. And we do that by writing books that are easy to read, attractive to read, but also in the way the assignments and tests are structured. The answers to questions at the end of the chapter and on quizzes and tests, they're always questions that you answer in complete sentences or computations. That's basically the only two kinds of test questions we use. We don't use multiple choice and so on because those things make life a little easier for the teacher, but they don't require the student to generate language for himself or for herself, and therefore they do not serve the student. By the way, I should mention that this whole philosophy is described in great detail in my book, From Wonder to Mastery. And I always encourage anyone using the Novare curriculum, if they haven't read From Wonder to Mastery, they should do that before they begin their first year. That way you'll understand the whole teaching model that I've just described, and you'll understand all the details of how to implement it and how to make it work most successfully. Now there's one more thing a couple more things that make our books really unique. One of them I'll mention is the accessibility issue. Students tell me all the time, they come up to me at conferences or other places and they say, reading your books is just like having you here talking to us. They're so easy to read. One student told me he took his book with him on his family vacation at Christmas so he could read it on the plane just because it was so much fun to read. So I'm really proud about this because when I started writing texts, I had no idea that they were going to be like that. I mean, I wanted them to be fun and easy to read and what good explanations of things. I didn't know if I was going to be able to accomplish that, but students tell me that that's how they are. So that's a really attractive feature. And it also means that the books are that much more easy to use in a homeschool context where you don't have a teacher to, answer lots of questions and repeatedly explain things. You need a book that is easy to read, that has very good explanations. And the last thing I will say is our approach to integrating faith into science study is also unique. We believe that students need to study mainstream science, and they need to understand the areas where there are controversies. But our books present the Earth as old, 4.5 billion years, and we believe the evidence for that is just massive. And so, but there's no conflict between this view and the Bible's description of how the world got here. So we don't discuss the whole biblical human hermeneutical business in our books. We leave that to others to do. We just talk about the science. In the subject of evolution, I'll just mention that what we do is present the theory without claiming that it's true, without claiming that it's false. There are Christians on both sides of this issue. I'm well aware of that. We leave that debate to others to read different books and support different points of view and learn how to interpret the Bible and so on. We leave that work to others. We just present the mainstream science and say, here's what the mainstream science is, and here's the evidence for it. But we're not claiming it's true. Well, the scientists don't claim it's true either. They claim it's their best explanation because that's what science is. All right, so what we're doing is integrating faith by pointing out that God is the creator. The creation is stunning and beautiful. It's obvious when you look at the creation that it was designed by an intelligent person with one with purpose and meaning. And so that is loaded into the books. That's our way of integrating faith. And students really appreciate this approach, that every 20 or 30 pages, when we come across something really fascinating, that's when we'll stop and say, this is where the fingerprints of the Creator are evident right here. I hope you've gotten your feet wet now with understanding our curriculum. I hope you'll visit other things on our website and learn more about it, or contact our sales staff. So God bless you.